எது வரைக்கும் முடிச்சிருக்கோம்? AC source connected across. AC source connected across series RC, correct? So the next thing that we are going to discuss is those who are online, are you able to hear me?
Yes, sir.
Okay. AC source connected across a series RL circuit. RL. Okay. Let's say the current flowing through the circuit is I. Okay. If the current through the resistor is taken as IR, you can keep it on top. And if the current through the inductor is taken to be also the same IR, why? Yes. IR is equal to IL. I can call it as I because they are in series. Okay, if this is IR, then how much will this resistance voltage be? VR. Now refer your previous notes. Okay, refer the previous topics and tell me how is the current, I repeat, how is the current with respect to voltage in a inductive circuit? For an inductor, check your notes and tell me. For an inductor, how is current and voltage related? So if E is equal to E naught sine omega t, I will be equal to I naught sine of for a capacitor. Means the current will lag the voltage. Current lags voltage by pi by 2. Then I can say voltage leads current by pi by 2. Okay. Then what will happen in this scenario is if IR is like this, then can I say VL will be like this, or I'll call this as IL, because we know that IL and VL, they both IL and IR, they both are same. So if IL is like this, can I say VL is in this way? Accepted. Again, because voltage leads the current by pi by 2. Now, if I try to draw a phasor diagram, if this is VR, with respect to VR, how is VL? In this way. Is that right? Because VR and VL are perpendicular to each other. Correct? Is that right? So when I say this is the case, then what is going to be the value of V effective? Root of VL square, or I'll write it as VR square plus VL square. So root of, can I write it as IR square plus I into XL square? So V effective is I into Z is equal to root of I square R square plus I square XL square. So Z will be equal to root of R square plus XL square. Is the point clear, guys? Breathe. Those who are online, are you able to understand? So Z in the impedance, in the case of a series RL circuit will be equal to root of R square plus XL square. Okay, please copy it. Now we'll go to the next topic of series LCR circuit. Means inductor, capacitor, and resistor. All the three are connected in series. Series LCR circuit. So when I say series LCR circuit, I'll first put the resistor because you can call it as RLC also. Now here resistor I'm putting it before is because with respect to resistor, it is easy for me to calculate for inductor and capacitor. R, L, and C. So if I say the current across the resistor is IR, current across the inductor is also IR, and the current across the capacitor is also IR. How is the voltage related to current in the case of resistive circuit? They both are in. So this is VR. What about IR? What about VL and IL? So the voltage across the inductor leads the current by 90 degrees, and the voltage across the capacitor leads lags. So we see. So if I take everything, and plot it like this. Here, sorry, VR, this is VR, this is VC. Okay. This is VR. This is VL minus VC. So what I did is, for example, I represent it with this color. VR and VL are perpendicular to each other. VR and VC are perpendicular to each other. Right? What is the angle between VL and VC? 180 degrees. They're out of phase. Now what I'll do is, if I take this and rotate it and put it here, then this will become minus VC here. VL minus VC here. So then what is going to be the value of V effective? V effective will be equal to root of VR square plus VL minus VC the whole square. So V effective is IZ is equal to root of I square R square plus I into or I square into XL minus XC the whole square. Okay, Z will be equal to root of R square plus XL minus XC the whole square. Is this clear?
Yes, sir.
So this will be the impedance in the case of a series RLC circuit. Right. Now comes the next important question of a concept called resonance. You've heard of this word resonance? Organic compound isomerism. I'm talking about resonance in the base level. But you've heard of this, right?
Yes.
You've heard of that experiment called sonometer? Sonometer பார்த்திருக்கீங்களா? Lab போனது. Okay, then it's fine. So you have a sonometer. Sonometer na அந்த wire மாதிரி இருக்கும். அது மேல you will keep a small paper. Tuning fork எடுத்து கிட்ட எடுத்து போனா paper கீழ விடும். Have you ever observed that? How many of you have done this experiment? Okay, இதெல்லாம் விட்டுரு. Okay, leave lab will come to our house. Let's say, I'm not sure you have experienced, I've done it, so எனக்கு தெரியும். Let's say this is your house. Okay. Let's say you're sitting in the hall. Unfortunately, your house is closer to the main road. Okay. And the road is also in such a way that it is not very well designed. On the main road, let's say there is a lorry that is crossing. Have you ever felt a slight vibration kind of thing here? Have you ever felt it? Standing on the road, have you ever felt it? See, for example, you are standing on a footpath. Sometimes there is a heavy vehicle crossing beside you. Have you ever felt a slight vibration here? Have you ever felt it? Right. So what is happening here is this vehicle is disturbing the particles which are below that. And those particles are transferring the energy to the place where you are standing. Basically, the objective of a wave is to carry energy from one place to another. You ask me why we are studying waves. Basically, you want to carry energy from one place to another. You need something called as a disturbance. Okay. When this is happening, you also start experiencing it. Means the frequency that is generated here is actually getting transferred to this place also. Okay. So whenever you say something is in resonance, right? Generally, we say that the frequencies are matching. And if I have to speak in simple, like in English, if I want to use the word resonance, right, I can say, let's say we both are thinking in the same way. Then I can say our thoughts are in resonance. Our thoughts are resonating. Have you ever heard this thing? They say our thoughts are resonating. Abdina, your thought and my thought, so we both are thinking to the same level of frequency. Okay, this task has to be done like that. Other than is on the higher level. I have to come back to what is the book definition of resonance, matching the force frequency to the natural frequency of something. Okay, when you match the force frequency to the natural frequency, then the object which is forced will start vibrating with maximum amplitude. So basically, whenever there is a condition of resonance, the object starts vibrating with the highest amplitude possible. So wherever you see the word resonance, what will you say? The first thing you need to understand is the object starts vibrating with maximum, highest level. I can use the word maximum amplitude. Okay. So this is what happens with respect to a wave. But if you have to speak about the same topic for a series LCR circuit, then what happens is, if you pass the current through the series RLC circuit, then what are the parameters you can change based on when the current through it will change? If there is the same source, right? E is equal to E naught sin omega t, it's the same source that you are connecting. But I'm saying that through the series RLC circuit, I want you to pass maximum current possible. What all you can change? You can change the value of LNC. LNC adjust பண்ணலாம். ஒண்ணும் இல்ல. What was the previous topic that we learned? We learned something called as impedance. Impedance, what is it? Impedance is what? It is basically like opposition. So impedance is the opposition offered by the series RLC circuit for the flow of charges. Can I say that? Can I say that? Yeah. So it is opposition offered by the series RLC circuit for the flow of charges. Now, when this is the case, how will current and impedance be related? Can I say current is inversely proportional to the impedance? Can I say this? Right. When it is inversely proportional to impedance, now what I'm expecting from a series RLC circuit is the current that you have passed through this device has to attain maximum value. If it has to attain maximum value, if current has to be maximum, then what should happen to the impedance? It should be minimum. So if you connect all the dots together, right, minus on the resonance now, maximum amplitude in the case of waves. In the case of alternating current, it is maximum current. So when will you say an LCR circuit is in resonant condition? When the current passing through the series LCR circuit is maximum. Is this point getting registered? Right? Those are online. Is it getting registered?
Yes, sir.
Yes. That is the most important point you need to have in your mind. When this is the scenario, observe. Can I write? So I'll just read it out for the last time. A series LCR circuit is said to be in the condition of resonance when the current through it has a maximum value. When the current through it has a maximum value. So if I take I naught, then I naught is equal to what? Can I write it as E naught divided by Z? Can I write it? So this will be equal to E naught divided by Z is equal to root of R square plus XL minus XC the whole square. Wait, I'll write it in a fresh page. So for a series RLC circuit, I can write it as I naught is equal to E naught divided by Z. This would be E naught divided by root of R square plus XL minus XC the whole square. Correct? Now what am I expecting? I'm expecting I naught to be I to be maximum. Then Z should be minimum. When Z should be minimum, I know that Z is equal to root of R square plus XL minus XC the whole square. Means it is actually the sum of two positive values. Can sum of two positive values ever be zero? Obviously not. So if I ask you A square plus B square is equal to zero, tell me what is the value of A and B. It is possible only when A is equal to 0, B is also equal to 0. That is the only condition possible. But in this case, if I write R as 0 and XL minus XC as 0, then there is no circuit at all in the first place. Circuit dilemma, what will I discuss about maximum current? So I need to either make R to be least or XL minus XC to be least. Means I can only make it least, I cannot make it 0. Means I need to make R as 0 or XL minus XC as 0. Either of them as 0, not both of them together 0 simultaneously. If I have to do that, I cannot make R equal to 0 because if I make R equal to 0, I can never define impedance. Yeah. Because for me to define impedance, I need to have a resistive element combined with a reactive element. Resistive element and other resistors. Reactive elements are what? Inductor and capacitor. That is why they have something called as capacitive reactance. அதே மாதிரி inductive reactance. Right. So those are reactive elements. So resistive elements and reactive elements put together is what is going to define your impedance. So R obviously I cannot make it 0, which implies XL minus XC can be a 0. So if the whole story I'm going to discuss one now, the whole story started with the fact that I'm talking about when will my LCR circuit be under resonance condition. So resonance definition, what is it telling me? It is telling me that the current has to be maximum. But mathematically, I'm able to understand current maximum impedance should be less. Impedance should be less doesn't mean it is equal to 0. Impedance lesser R square plus XL minus XC the whole square should become least. So the least R cannot be 0, whereas XL minus XC can be a 0. So from this, what are the important points that we can conclude is during resonance condition, a series RLC circuit behaves as a purely resistive circuit. Underline this. A series RLC circuit behaves like a purely resistive circuit. Though you have inductor and capacitor connected in a series RLC circuit, the values of the reactances will be in such a way that they will get cancelled out. Purida, am I clear? When I say XL minus XC0 implies XL is equal to XC. XL would have value another omega into L. XC's value is 1 by omega C, which implies omega square is equal to 1 by LC. Then what is the value of omega? 1 by root LC. And this omega is equal to 1 by root LC is what is called as resonant frequency. Is that clear, guys? So you write it as omega r is equal to 1 by root LC. But I can write omega r as 2 pi into fr is equal to 1 by root of LC. So fr will be equal to 1 by 2 pi into root of LC. It's very, very, very important topic. There's a very, very, very important mathematical expression in this chapter. And based on this, many problems are asked. Surya. Now, what I can say is, there is a concept called as sharpness of resonance. Okay. So till now, we had been studying and discussing things continuously, but we don't know why we say. So let it be. I agree with that. Why do we need it? So there is a branch in engineering. There is a branch in engineering called as circuit theory. Okay. So in the circuit theory, the main job of them. Switch on maybe down the page. Yeah. Those are online. Are you able to see me?
Yes, sir.
Okay, listen. So till now we had been discussing about what are the resistance, reactance, whatever nonsense was possible. We discussed everything. Series R, series R, C. So what related them exist? The theory is done. What did it say? There is a branch called circuit theory. Our main job is to design devices called as filters. These are not the filters that we use for a decaution system. What is a decaution filter? Why do we use a filter in the first place? To separate something. To separate something, what is that something? You want the unwanted particles to be kept as a residue. Whatever you need, you pass through it. Correct? When you use this resistor and capacitor, we discussed that resistor and capacitor were connected in series. But is it necessary that they need to be connected in series always? Why can't you think of connecting them in parallel? When you do that, there has an application of start behaving as a filter. So you behave like a filter. So filter there is about how a particular frequency can be cut off, or how a particular frequency can be allowed to. For example, we listen to FM, right? When we go in car, we listen to FM. Generally, FM basically the radio wave. And the 98.3, 92.7, whatever they call it, what are they actually? And the frequency, if we are talking about what value it is. Frequency is right. Frequency is measured in hertz. Correct? But what hertz is that radio frequency measured in? The 92.7 is the frequency. Is it measured in hertz? Is it measured in millihertz? Gigahertz? Terahertz? What is it? It's measured in megahertz. MHz is the next step over the radio part of the era. It will be written as MHz. M stands for megahertz, 10 power 6. Here, radio waves are in that particular radio waves will actually frequency range of 88 to 108 megahertz. Everything will be within that range. So when you're tuning to a particular channel, as an end user, how will you feel if some other channel is interrupting? You will participate in something which is a favorite song. suddenly some other channel they are speaking and that gets interrupted. As an end user, you get irritated. But that frequency is also there, this is also there. Why will they not interfere? Interfere na puriyudha enna solranga. Oru wave போகுது. அந்த wave போயிட்டு இருக்கு actually. That wave is also traveling. But why are they not actually when they get interfere ஆகும், but if certain frequencies are getting cut off. அது எப்படி கரெக்ட்டா 98.3 தான் வருது. அப்படி பார்த்தோம்னா அதுக்கு அந்த sharpness சொல்றோம். That's why it's called as sharpness of resonance. Another topic means how sharp. See, like originality, I'm not sure if you guys have experienced it. Originality on the blur or very hissing sound of it. Then you try to do fine tuning. Like you do a fine tuning so that okay, and the antenna on the signal that receive you will be able to hear it perfectly. So adala eppadi nadakku? How is it happening? Back end there are certain electronic components that are used which are called as filters. And the filters there are different types of filters that we use. One is called as a band pass filter. Band pass is certain bandwidths only level. If I write a program in such a way, the bandwidth it will allow only that bandwidth. Similarly, if you want to allow high pass filter, it will allow only high frequencies. Low pass filter, bass voices. So who's acting as the main component of all those devices? The same resistor intercurrent capacitor that is you will have on a small board actually. Radio you will have a small board like this, which we call it as PCB, printed circuit board. You will see certain components which are present. Motherboard it's a PCB. Resistor capacitor. Radio its main functionality is only to filter the antenna or signal. The filter it should give you another originality when you adjust it like this, right? Antenna or character receive but at the antenna just by pulling the antenna, how are things getting fine? Because inside circuits are working in such a way, you are giving an instruction to the inside devices and the filters. So we are actually studying. That is why the name of the topic itself goes as sharpness of resonance. So when will I get that particular sharp frequency that I require? Because there is a logic that is used in tuner circuit. So this is how things work. Mainly for communication. Communication and not the way we talk. So communicating from one part of the country or one part of the world to another. Satellite communication or space communication, what do we call it? Or ground wave communication. So if you want to do certain things, there are certain ways in which you need to transfer those frequencies. Communication sector is very good for you. Keeping the aside, this is the outline. So shall we proceed? Guys, I hope you could understand. Those who are online, I hope you could understand what I mean. I think they slipped off.
Yeah, I understand, sir.
Understood? Huh?
Yes, sir.
So we'll proceed with this sharpness. So for you to define sharpness, there is something called as Q factor, Q na quality. We call it as quality factor. Okay. So if at all I draw a graph which shows a variation between current and angular frequency. Okay. So which current? Current amplitude. So if I draw the variation of amplitude of the current versus omega, I is equal to what did we write? I naught is equal to E naught divided by root of R square plus omega L minus 1 by omega C the whole square. We wrote it in this way, right? So if you observe, I naught is a function of omega. When you draw the graph, you get these kind of structures. Okay. One will be something like this. And the second will be something like this. I suggest you guys to draw it along with me. I'm tracing it, you draw it. So third is something like this. Okay. Now you have The first graph, because you connected across a series RLC circuit where the resistance is low. So obviously resistance kammiya irundha, what will happen to current? Maximum irukuma. So adanal inga maximum irukku. Okay. But in the question, you drew the graph between I0 and omega. Okay, first draw it, then I'll explain. Let me know once you're done. Okay, done. So what is this frequency that corresponds to the maximum value of current? That frequency is what is called as resonance frequency. In a resonance frequency, you will have the maximum current. Okay. Now what will happen? So this is how the graph is. So in your low resistance, you have moderate resistance and you have high resistance. I need to define something called as a quality factor, which defines the sharpness of my tuner circuit. So the quality factor enadana. So when I talk about a series resonant circuit, the quality factor is defined as the ratio of I'll take one of the graphs. So one of the graphs is like this. This is for low value of resistance. So what is this value? Omega R. So quality factor is defined as a ratio. Observe. Quality factor is defined as a ratio of resonant frequency to the difference in two frequencies taken on both sides of the resonant frequency. So on either side of the resonant frequency, I'm taking two frequencies, omega 1 and omega 2, such that the current amplitude at that point becomes 1 by root 2 times the maximum value. If I call this as maximum, then 1 by root 2 times maximum is somewhere over here. Okay, divided by omega 1 minus omega 2. Means I took omega 1 and omega 2 in such a way that the corresponding value of current for omega 1 and omega 2 are I max divided by root 2. Is it clear? So you call this particular ratio as quality factor, and this omega 1 minus omega 2 is what you call it as bandwidth. Am I clear?
Yes, sir.
So at omega 1 and omega 2, the value of I naught will be 1 by root 2 times I max, and the value at omega r will be equal to I max. So this is how you write it. So difference can be omega 1 minus omega 2 or omega 2 minus omega 1. You know the difference between difference and subtraction, right? Another. The difference of 1 and 2. Sorry, the difference between 1 and 2 is how much? Difference between 1 and 2 is 1. Subtraction of 1 and 2 minus 2. So difference is always possible. So 1 minus 2 difference in and geta, you can do either 1 minus 2 or 2 minus, but you will report only the positive value. So adhanal I wrote it as omega 1 minus omega. You can also write it as omega 2 minus 1 no harm. Okay, that omega 2 minus omega, call it as bad. In this way, if you this is delta omega, and if you say this distance is also delta, then you q is equal to omega r divided by 2 times delta omega. Delta omega and another. If I say delta omega is equal to omega r minus omega 1, or delta omega is equal to omega 2 minus omega r, they both will have same magnitude. So omega 2 minus omega 1 will be how much? 2 times delta omega. Okay, and there is another formula also which is not a part of, so derivation is not a part of your syllabus. So quality factor is also given as 1 by r into root of L divided by C. Take it in this way also. Okay, so just give me a minute, we'll do some problem based on this concept. So, oh, sure. So, we'll do problems tomorrow. I have to search for the assignment. So, we'll discuss one last concept for the day, which is called as power in an AC circuit. So, when I say power in an AC circuit, generally, what does electrical power mean or electric power mean? It is a product of E and I. Is it right? E is equal to, if I take it as E naught sine omega t, and I take it as I naught sine of omega t plus phi. Why did I take it plus phi? Is because if I take it as omega t, then I'm saying that the circuit is resistive circuit. It need not be always known. Right. Now, if I define P is equal to E into I, can I call this as instantaneous power? Instantaneous EMF into instantaneous current is going to give me instantaneous power. As simple as that. Correct? So P will be equal to E naught sine omega t into I naught sine of omega t plus phi. This is right, guys. Right. So I can write it as E naught into, observe, I can write it as E naught into I naught into sine omega t into sine of omega t plus phi. Now what I will do is, since I have sine into sine, I'll multiply and divide it with 2. Those who are online, I suggest you guys to write it along with me and concentrate. This is clear. So I multiplied and divided with 2 so that I have a formula like this. So cos of a plus b minus cos of a minus b is equal to minus 2 sin a sin b. So I get cos a cos b minus sin a sin b minus cos a cos b plus sin a sin b. Wait, sir. So minus 2 times sin a sin b is going to give you the answer. So that will be the answer. So what I can do is, if I want only 2 sin a sin b, then can I write this as cos of a minus b minus cos a plus b? Purida. So since I have a positive value here, this I will write as E naught into I naught divided by 2 into cos of a minus b omega t plus phi minus omega t in minus etc. So I took the bigger number as a. See, it's not necessary that you need to take the bigger number of a because cos of minus a is also cos a. Cos of minus theta is cos theta. Here we'll get the same answer. But for safer purpose, I took it like that. So omega t and omega t are gone. I can write it as E naught I naught by 2 into cos phi minus cos of 2 omega t plus phi. So what is this value? This is the expression for instantaneous power. Any doubt till this? Yeah. The value of instantaneous power. Now, I want to find the average power over a complete cycle. Can I do that? So average power over a complete cycle. So P average, can I write it as integral of 0 to t P times dt divided by integral of 0 to t dt. Can I do this, guys? Panlama. This is the meaning, right? Because average value of a function over a given cycle is 0 to capital T f of t dt divided by integral of 0 to capital T dt. Same logic, f of t, I wrote it as power because power itself is a function of time. Power is a function of time. If I do this, now observe. T average will be equal to 1 divided by capital T into integral of 0 to capital T. P is E naught I naught by 2 into times dt in Rama. Can I write it in this way? So what will happen is E naught I naught divided by 2t into integral of 0 to t cos phi dt minus integral of 0 to t cos 2 omega t plus phi dt. Can I do it in this way? So this will be E naught I naught divided by 2 capital T. This cos phi will come out of the integral. So cos phi into integral of dt is capital T minus, remember, any sinusoidal function, whether it is a cos or sine, which is a function of time. I repeat. Any sinusoidal function, whether it is a function of cos or sine, which is a function of time, over a complete time interval is always 0. You need not even sit and calculate it. You know? When I look at the graph of cos, it goes something like this. This is 0, this pi by 2, this 3 pi by 2, and this goes to 2 pi. Plus and minus. The sum of these two plus will be equal to minus, so that the average value over a complete cycle is always a 0. Now you can ask me, sir, why didn't you cancel out cos phi and make it a 0? Why didn't I do it? Say if I say cos 2 omega t plus 5 over a complete line interval 0 to t is 0, cos phi should have also been 0. Like, it is 0 it is a constant because it's not a function of time. Whereas here it is a function of time. So what the important point I want you to note it down is average value of sine and cosine function over a complete time interval is always right. So minus, obviously in the 0 then over I'm not going to write it. So what is the time left out with? So this t and t will get cancelled. This E naught I naught divided by 2 times cos phi is going to be the average value of AC over a complete cycle. This I can write it as E naught divided by root 2 into I naught divided by root 2 into cos phi. What is E naught by root 2? I naught by root 2 IRMS. So you can write average power is equal to ERMS into IRMS into this cos phi is there, right? This cos phi is called something as PF, which is power factor. I'll do one thing. I'll write it cos phi. And this cos phi is called as power factor. Average value is equal to ERMS. So how will this help us to understand whether the circuit is There is a lengthy derivation. I suggest you guys to practice that. This is how it works. Power factor also has a significance. We will explain it in the next class. So any other doubt? Right, those who are online, any other doubts?
No, sir.
No.
Okay, then we'll wind up.
Yeah, bye, sir.
Thank you, sir.
Yeah.